Radioactivity is the act of emitting radiation spontaneously to stabilize the atom, which releases energy and radiation. Radioactivity is also known as a phenomenon exhibited by few matters that release energy and subatomic particles spontaneously. That's why it is known as radiation. The elements shown in the periodic table, as you are able to see in purple color, are all the radioactive elements out of 118 elements in our periodic table. An atom of a radioactive element is shown here. As you can see, the radioactive element's atom releases alpha, gamma and beta rays. The alpha rays are nothing but alpha particles having 2 protons and 2 neutrons. Gamma rays are particleless, they are energy radiations, while beta particles are electrons emitted by the radioactive atom of matter, such as uranium, radon, radium and polonium. When experiments are performed to see which ray is carrying which charge, the rays are passed through a lead block in which radioactive substance was placed through a tiny hole in a slit. Then, in front of the slit, 2 plates carrying opposite charges. On the upside positive and on the lower side negative charge plate is placed. Then the rays are allowed to pass through the slit. The rays are deflected towards both positive and negative charges. The rays shown in yellow are migrated towards the positively charged slit, so definitely they are carrying opposite charge, that is negative, and the alpha rays towards negative plate. It means the alpha rays are positively charged, that's why I got attracted towards the negatively charged plate. So what about the gamma rays that are passed through the slit were electrically neutral, so they traveled straight in the path over the zinc sulfate photographic plate. This confirms that beta rays are negatively charged particles and the alpha rays are positively charged particles. Now let's discuss about isotopes of elements. What is an isotope? As you can see in the image, isotopes of hydrogen are shown here. So as you can see, the normal hydrogen atoms at the center is having only 1 proton, there is no neutron, and 1 electron, and another atoms are shown on the below side of the original atom of hydrogen, that is having 1 proton and 1 neutron in the center, known as deuterium, and an electron is revolving around it. And another atom of hydrogen is shown on the side of deuterium, that is tritium, having 1 proton, 2 neutrons in the center and 1 electron revolving. It means that an isotope of hydrogen is having 1 extra neutron or 2 extra neutrons, while the protons and electrons in the atom remains same. So the only difference is difference in the number of neutrons or presence or absence of neutron in hydrogen atom. Let's see another example. Isotopes of carbon are shown here. The carbon is having atomic number 6. It means it has in the center 6 protons and 6 neutrons, while 6 electrons are around. In the case of the first carbon. What about the second? Let's see. There are 6 protons, 6 electrons, but there are 7 neutrons, means 1 neutron is more. It is an isotope. Now let's see about the third atom shown here. That is having 6 protons, 6 electrons and 8 neutrons, means it is also an isotope because neutrons are more than normal.